for a particular material, if you have a piece of paper or something, you can fold it into boxes of various volumes, or it can be taller, it can be shorter. The idea is to optimize it. How do you optimize it? That means, how do you find the maximum or how do you find the minimum so that it is perfect for your particular situation? So that is the idea. So a company is asked to make a rectangular container for storing stationeries. They must use a 20 centimeter by 20 centimeter square board like the packets they make in shops. So this is 20 centimeter, so around here, and it's 20 centimeter, so it's a square. To construct this, 4 squares need to be cut out from the corners of the cardboard. So we don't know what the 4 square size would be. Let it say this is x. So this is x, this is x, this is x, this is x. So it's like x everywhere. So this is x, this is x. So we are cutting out these 4 squares around the corners. Okay. So when we cut it out, so what would happen? So that it can be folded into a box. So let me remove the corners. Okay, so this is what it would look like. Now we have to fold it. So take a look over here. So what we have over here is the box after it has been folded. So you can see that obviously the height over here, it should be x, because when we folded the corners, when it was open, it was x. So when we fold it, this is what it looks like. And so how can we find out an expression for this? Because first of all, we have to find out an expression in terms of one unknown quantity. So let's see. What should be the height of the box if we want to maximize its volume? We want to make the box such that it has the maximum volume under these restrictions. What are the restrictions? It's a cardboard 20 centimeter by 20 centimeter and the corners are cut out. We don't know how big the x would be, but we know the height would be x as we fold it. As you can see here, after you fold it, it was first flat. This is the height and that is x. So we can see that. So what should be the height of the box if we want to maximize its volume? So first of all, let me draw a picture. A picture always helps. So if this is the picture of the box, then we know this is x. This is definitely x. And this length around here, this would be 20 minus twice x, because the whole thing was 20. If you remove x, this length would be 20 minus twice x. 20, this would also be 20 minus twice x. So we know this one, when we fold it, this particular value would be 20 minus twice x. So this is 20 minus twice x. This is also 20 minus twice x. And the height is x. So we can find an expression for the volume. So volume is length into breadth into height. So 20 minus twice x into 20 minus twice x, that means 20 minus twice x whole squared, and into x, that is the height. So now we can find an expression. So first of all, we have to break down the brackets. So 20 minus twice x whole square is going to be a square minus twice ab plus b square. So 400 minus, so this is going to be 2ab, 2 into 20 is 40, 40 into 20 is 80, so 80x plus 2x whole square is 4x squared, and we have an x here. So then we multiply this would be 400x minus 80x squared plus 4x cubed. So now we have an expression for volume. And this is a bit, if you notice this is like a Cartesian equation. Instead of y, we have v. So this is like a Cartesian equation, and you remember a Cartesian equation has a shape like this, nu. This is what the shape it has, and the maximum value would be somewhere around here. So basically what we're looking for the turning point. That's what we're looking for. So now what we have to do is we have to find the height. So x, we have to find the value of x for which it is maximum. So we can write, first of all, dv by dx. So at the maximum value, at the maximum rate, So dv by dx, the derivative would be equal to 0. So dv by dx is 400, x is 400. The derivative of 80x squared is 80 into 2 is 160x plus 4 3 is 12, x squared equals to 0. So first of all, let me simplify this by arranging it. So 12x squared minus 160x plus 400 equal to 0. I can divide this with first of all 2, the 6x squared minus 80x plus 200 equals to 0. Then I can divide this again with 2. So this would be 3x squared minus 40x plus 100 equals to 0. Now I have to find the two values of x. Let me do this very quickly. So we have x equals to 10 or x equals to 10 by 3. So how do we know which one gives the maximum volume? How do we know? So now we have this step. We have to check with the second derivative. So let's do the second derivative over here. d2v by dx squared, and that turns out to be derivative of 400 is 0. So the derivative of minus 160x is minus 160 plus the derivative of 12x squared is 12 to the 24x. So we got the second derivative. Now we have to plug in to see which one gives the value to be negative, because if the second derivative has a negative value, only then it would give a maximum value. So if we put 10 over here, 240 minus 160 would be positive. If we put 10 by 3, so when x equals to 10 by 3, we can see d2v by dx squared is going to be, this is minus 80. This value doesn't really matter, but what matters is that it is negative. Since d2v by dx squared is negative, x equals to 10 by 3 gives the maximum volume. So the height should be, 10 by 3. If it's centimeter, it's 10 by 3 centimeter. That turns out to be 3.3 centimeter. What should be the maximum volume? Now we can find the volume. Just plug in the value of the height, which is x, and we can find the maximum volume. So when x equals to 10 by 3, the volume would be 400 into 10 by 3 minus 80 10 by 3 squared plus 4 into 10 by 3 whole cubed, and approximately 593 cm cubed.